Hello, in this problem we will see an IB question which is based on t-test, two sample t-test and chi-square goodness of fit. Let's see the problem. Scientists have developed a type of corn whose protein quality may help chickens gain weight faster than the present type used. To test this new type, 21-day-old chicks were fed the ration that contained the new corn, while the other control group, 20 chicks, were fed the ordinary. Data is given below in grams. Now, what the first question says. The scientists wish to investigate the claim that group B gain weight faster than group A. Test this claim at 5% level of significance, noting which hypothesis test you are using. You may assume that the weight gain for each group is normally distributed with the same variance and independent from each other. Now, these are all the most important information that they give that I have to pay attention to so as to solve the problem. So now I have two groups, group A and group B, where the one is given the corn with the protein and the other one with the normal one, the ordinary one. Now we want to see if group B gain weight faster than group A. Immediately, if you want to compare two samples, you have to understand that you have to use the t-test the t-test for the difference of two means. The assumption is that the two populations are approximately normal distributed and the samples are random. Now, so what I will use t-test, okay, of the difference of two means. That's my test that I will use, so that's my answer concerning which test to use. So my hypothesis, my null hypothesis, will be which one? I want to see if the two means are equal. Alternatively, you can write it like that: me1 minus me2 is 0. That's my null hypothesis. And my alternative hypothesis will be my mean 2 is bigger than mean 1, or you can write it like this: me1 minus me2 is less than 0. So if I want to check my how I will do it, because they ask me test this claim at 5% significance. So what should I do? I go to my calculator. Let me bring my calculator here. And now I should do what? I will go to my lists. Where is the list? Here. Edit. And as you see, I already input the data. So you have to do the same. L1 I will put my ordinary, and L2 I will put the new corn. And then I will go to my test and I will make, here, a two sample t-test. Now I have data here, I don't have statistics. I have L1, it's my list of the ordinary group. L2, second L2, frequencies list like that. Now my mean, I want to be the second one I want to be bigger. Pool data, yes, in this case. Why? Because they tell me here that it is they have the same variance. So whenever I have the same variance in my problem, if you will see it, it says the same variance here. So basically I will that means that my data are pooled. So now I will conduct my test. Sorry, yes, pooled, yes, and then calculate. Now here I have what is my critical value, minus 2.46, and how much is the p-value? The p-value, as you see, it is 0.009. So here now I will say p is 0.009, which is less than 0.05. So what should I say in this case? I reject my null hypothesis and I say that group B grows faster. So this is for the question A. Now I'll go to my second question of the problem, where it says the data from the two samples above are combined to a single set of data here. The following frequency table gives the observed frequencies for the combined sample here. The data has been divided into 5 intervals. You see the intervals here. Test at 5% significant level, where the combined data can be considered to be a sample from a normal population with a mean of 380. Now here, if I want to check if my sample are coming from a specific distribution or a normal population, it's the same, I must understand that here I must use the chi-square goodness of fit test. Now I want my goodness, my chi-square goodness of fit test. So as to conduct it, I need my, apart from my observed data, I need also my expected data. Now, how much I expect to be, if it's from a normal, I must have some expected values. How I will calculate that? To calculate it, this one, first, now, if it comes from a normal population, it means that it should follow a normal distribution with a mean of 380, comma, the normal distribution is mi, comma, sigma. Which means I must find my variance or the standard deviation. I don't know it. How I will calculate it? I will calculate it from my data here. So I will take all this data and I will put it inside, import them into my calculator. Let me bring again my calculator here. Now if you will see, I'll go again to the list here. If you will see here, I input in L3 all my data here, both of them. Now let me find the variance, the standard deviation. So the standard deviation here, I'll go second quit, I'll go to my stat and I will calculate one variant stats. List is L3, calculate, and here I have my standard deviation, which is 49.59. So here I have 49.59. Now I found my standard deviation. Now I have to find the expected frequency for all of my data. How I will do that? It's an easy process. You have to understand now that, for example, to find the expected value of the first for this interval 271 up to 310, I must find the probability that to get 2 out of all of them. Which probability of the normal distribution? So I will bring again my calculator here and I will try now. I'll go to my distributions, second distributions, and I will calculate the probability here of what? Now let me have it here. So I have expected here, the expected I will write it down. Now I need to find the probability of what? If you will see here 271 up to 310, but to calculate the probability in an interval I should not include 71 because I want also 271, and I want also 310 as a value to calculate the probability. So as a lower boundary I will put 270.5, one before 0.5 before 271, and an upper boundary I will put 310.5. Now the mean they told me is 380, and my standard deviation is 49.59. I will paste it, and I find that the probability is 0.0669, which is, so for the first one 271 310 2. Now the probability of gaining that is the probability of 271 up to W 310 is 0.06. Okay, how many data do I have here now? Altogether my data are 40. So basically now I just need to calculate how much is 40 times 0.06, which is 2.4. So here for this value it's 2.4. Now for the next one, the probability of getting 311 up to 350, how much is it? Again, calculator, second distribution, CDF. Now my lower boundary should be 310.5 and my upper will be 350.5. Same, 0.195. 0.195. So how much is the expected? Again, I have to multiply to see how much is it. 0.195 times 40, 7.8. 7.8. So let me calculate. I will stop the video so now all the values, and as you see, I imported all the, I calculate all the expected values from the probabilities. Now how I should input these values, the observed and the expected, in my calculator. But before doing that, always I must pay attention if I have any value less than 5 at my expected values. And yes, there is one value. Be careful, this is a point where many students forget that. So this is 2.4, so I will combine the adjacent rows or columns that I have. So here, these two columns, they will be merged. So that my new table will be 2 plus 9 is 11, and the expected is 10.2. And then I have 8, 12.32, 15, 10.48, and 6, 6.17. This is my observed, and this is my expected. Now the degrees of freedom, since I have 4 rows, it's going to be 4 minus 1 and minus 1 from the also rows and columns. So the degrees of freedom are 2 degrees of freedom. So now I can import everything in my calculator. Let me bring the calculator here. So yes, first I will go and import my observed and the expected in the lists. So as you see, I already did it. So now I will go and calculate my chi-square goodness of fit. Observed is L4, expected is L5, correct? The freedom degrees is 2. So now I calculate, and I get my value 0.17. Now, what happens is that my p-value is 0.17. Okay, let me, my null hypothesis is that my test, my sample follows normal distribution, and the alternative is that it doesn't follow normal distribution. So my value is 0.17, which is what? It is bigger than 0.05, which means I cannot reject null hypothesis. So yes, I say that it follows, it is coming from a normal population.